Yes, hydrophobic and hydrophilic part will be there. So, Beta, let's get a quick recap. Tomorrow, chemistry I'm doing. Okay. So now listen, chemistry you want carbonates compound now, CC. So now we are going to do that work. Now please pay attention, carbonates compound. So now listen, everyone, please inform in the group to join as fast as possible. We'll have a very important section. Hey, first, what and all about magnetism we have learned? First, magnetism is whenever any magnet will be there, magnetic lines of forces will be there. So these magnetic lines of forces are intersecting each other, na? No, the magnetic lines of forces are never intersecting each other. Listen carefully. The magnetic lines of forces are intersecting each other or non-intersecting each other? Non-intersecting each other. Why? Because the tangential lines are there. So these tangential lines are intersecting each other. So if the tangential lines will intersect, the direction will change. Where we can find a strong magnetic field? Near the poles or away from the poles? Near the poles. Understood or not? So another important question was ki when we are seeing different type of magnets, which magnet is supposed to be the most stronger magnet? Bar magnet or any type of irregular shape magnets? Bar magnets. Very good. So there are some questions are there. Porni, good evening. Monkey. So definitely now we are going to check. I'm going to check when all are present today. Sharmila, Ashwita, Vendan, Kavya, Himanshu, Mukundan. After that, Tapashwini, Porani, and then Divya, and then yes, all people are present. Very good. Yes, Maha, present, super. Informing the group to join the session as fast as possible. So now listen everyone very carefully. So magnet is not only thing that is producing a magnetic field lines. You need to understand that our earth is also acting as a magnet, and we also know a very important part. Yes, so we also know a very important, close that gate beta. We also know a very important part, and that very important part, Jotam, please remember this part. Just close it. So now, yes, you need to understand that. Elaversion, good evening. Inform all the students to join because my final sessions will be very, very helpful for you people. So, what? Blessing school students are down doing what? Waiting for rain? Can you go and shout on them? See, Kushbu auntie is shouting on. I should go and call. Kritika, you go and shout on them and say that man is shouting. Man is shouting very badly, you say. Live is buffering? No? From my side, it is not buffering. Is the live buffering for everyone? Your bag is there. He took it. Okay, only for you it is buffering. For others, it is also buffering. Wait, I've checked myself live. I'm checking. Otherwise, okay, otherwise I'll change my network. Now look here. So magnet is not only the thing that produce a magnetic field, electric field also generate magnetic field. So today we are going to do Oyster's discovery. Now he was the one who has observed it. His name was Hans Christian or Oyster, and AR and R that they will never be asking. Okay, so now the magnetic effect of electric current can be very easily be demonstrated. We can demonstrate this magnetic effect of electric current. Understand now how we are going to do this? By using a compass. So if we are going to bring a compass near, good evening Ilavarsan. So we are going to bring a compass near a magnet. We will be, thank you, come fast. And what you people were doing now? You were cleaning my garden. Give me 2 seconds. Some monkeys are coming and sitting. They are making some very nice sound. Yeah, connection is unstable. I can also see. Just 1 minute, 1 minute, 1 minute. I am seeing that part. Ishrat, good evening. Now listen, everyone. Oh, oh, oh. Fine. Now you need to check that. Is it now okay? Is it now okay? Okay, fine. Now listen, if it will buffer means you inform me, I'll change it. Now listen, beta. So Oyster is the one person who has exactly explained that you find electrical, what you call, when the current will be flowing in a conducting wire, there is a magnetic field generated around it. Understood? Now, which direction the magnetic field will be generated, how it is going to be generated, everything he has demonstrated it very nicely. And based on that, always one question is asked in CBSE. Specifically, they deal with direction very nicely. Understood? So, oystered magnetic concept of current exactly moving around means if the current is flowing in this direction, perpendicular magnetic field will be there. But the compass needle deflection is a very important point to remember. Understood? So compass needle will deflect. Everybody check you are live or not. Compass needle deflection moving is a very important thing we need to understand here. So north to south or direction we need to check. Still buffering. Yeah. Anybody is having network? I think it's okay only now. Is it buffering now? Check everyone. Check yourself now. Fine. Sometimes network issues are there. Yes. Good evening, Ashish. Now is it breaking? So now look a bit up. So we need to understand about Oersted concept, and Oersted has exactly explained about this concept. Now let's talk about this. Okay, so now we are going to go for the direction. So practical learning we are going to do. Practical learning is one by one, line by line. I will explain, and I will explain it how it is exactly done. Correct now? So the first point is place a magnetic compass on a wooden or plastic block. Okay, so one by one I'm reading it and explaining you. Got it? So that you will not miss out anything. So first we are going to take what, beta? We are going to take a magnetic compass. Where we are going to take? In a plastic block. Understood? Now away from all magnetic material. When the compass needle comes to rest, fix a wire over the compass. Are you understanding? So the compass needle should not have deflection. Got it or not? Because see, beta, understand, if I'm going to keep a compass, na magnetic compass, the magnetic compass will show deflection because of 2-3 things. Understood? Earth geographical north, it is going to show towards north. Understood? Of any other magnet will be present there, then that magnet will create magnetic lines of forces. Understood not? So that magnetic lines of forces will also disturb the compass. Are you understanding? So for that, the first crucial part is what they are doing is they are keeping it in on a wooden or a plastic block. So this is the first work. Did you understood the first work, beta? We are going to keep it where? In a wooden or a plastic block. Understood? Once we have kept it in a wooden or plastic block, after that we are arranging wire. We are arranging wire. Understood? So now the needle is not deflecting at all. Listen carefully. What is the precaution? The needle should not deflect. Understood? Then only we can be able to get a precise reading. Parani, are you there? So now look here. So when the compass needle comes to rest, I am reading one by one, line by line, and explaining you the parts so that you cannot. So compass needle comes to rest. So if it is coming to rest, then only we are going to start our next work. What is the next work? Fix a wire over the compass. So if this is the compass, so we are going to fix a wire over the compass. Understood not? So we are fixing a wire over the compass. So now parallel to the needle. So that means what? The compass should be what? It should be parallel to the needle. Got it? So how we are doing it? So if, yes, parallel. So if the needle is like this, the wire is like this. Understood? Either compass is down or compass is up. So but the needle is exactly parallel to the wire. So two things we understood. First, the needle should not keep on rotating. Why? Because that means there is another magnet which is influencing the compass. So for that, what we are going to do? We will keep a compass in a wooden box or a plastic box so that its deflection should not be there. That means it's not interrupted by magnetic lines of forces of nearby magnet. Understood? So it's not deflected by nearby magnetic. Understood not? After that, we are going to fix a wire. After that, what we are doing? We are fixing a wire parallel to the needle. After that, what? Parallel to the needle. Connect the wire to the battery. Now wire is getting connected to a battery from a switch. Now shown in the figure. We'll see the figure. Now close the switch to pass the current. So the moment switch is exactly closed. Now compass, what will happen to the compass needle? Still now it was steady. It was parallel to the wire. But the moment we connected it, what happened? The moment we are connected it, what is exactly happening now? Understood not? Will get deflected and come to rest at right angle at the original position. Understood? It is deflecting it and it is coming to rest at right angle. So if the direction of the current is from south to north, so current direction is south to north, the north of the needle will come to rest pointing towards west. Are you understanding? So now we are going to clear cut understand this. Now very slowly I have read out. Now I'm going to explain this part very clearly. See, the wire is exactly allowing current. Which direction the wire is exactly connected to? Can you tell me? Compass is also like this. Correct? Now the compass needle will get deflected and come to rest at right angles to its original position. So if this is the original position, it will come to right angle. So what is the, if the direction of current is from south to north, so this direction is east and this direction is west, but where the compass needle deflection will be towards west. Did you got this point? This is a clear cut point. Did you got this point? This is exactly clear cut. Now the current is moving from south to north. The compass needle will deflect towards west. Understood? So now look here. The north of the needle will come to rest pointing towards west. Note down, draw it in your note, please. Everyone, draw it in your note, please. I hope you might have understood this one, beta. Is it okay for you now? Did you understood this part? Yes. So it will be pointing towards which direction? It will be pointing towards east or west, Ray? Paityam? Yes. Still buffering. Now look here. Did you understood till here? Current is moving from south to north. It was parallel to compass. Compass needle went towards west. South to north means west. Got it? But it was first parallel. South to north, south to north. It went towards west. Current is moving like this. So it is which direction? Perpendicular to electric current movement. So current is moving from south to north and magnetic lines of forces are perpendicular to electric field. Understood? It will be perpendicular to electric field. Now we are going to talk about the next part. The north pole of the needle will come to rest pointing towards west. So now hold the compass above the wire. First it was below the wire. Understood? It was what? Below the wire. So that means we are going to create a conclusion. The needle will get deflected in the opposite direction. So this time it is going to deflect towards west direction or east direction? East direction. So above or below, the direction is exactly changing. Above or below, the direction is exactly changing. Let's have a full conclusion about it. The direction of deflection will change if you reverse the direction of current. Understood not? So current direction also, if you are reversing, it will get reversed. So first conclusion is what, beta? Can we come to know over a conclusion here? The last part, can you read? The needle will get deflected in the opposite direction. When? Now, hold the compass above the wire. First, what you did? This is exactly, now we are going to demonstrate it. Okay. So, in the demonstration section, this is the wire. Got it? The current is flowing from south to north. Initially, the needle location was there. It is below. The compass, this was the compass, and the compass is exactly below. So once the compass was below, it, after that what happened, which direction it got deflected? Towards west. Understood not? So now same compass we kept above here. Got it? The current is moving from south to north. So the moment we did like this, see what they told. If the current, the north pole of the needle will come to rest pointing west. Now hold the compass above the wire. Above. This is below the wire. Understood? The compass is here what? Below the wire. Now the same compass is exactly going above the wire. Now the compass is below the wire or above the wire? Above the wire. So the needle will get deflected in opposite direction. So this time the needle deflection is in which direction? This time it is moving towards east. Is it true? Did you understood? Note down, please. Draw this in your note and remember this. It was moving towards, first it was moving towards, here it was moving towards west, and here it is moving towards east. Is it clear? Check your live is okay. Vendan is telling Poranay is not there. Poranay? 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 Sometimes network glitch might be there. Poranay? Hi Ranjit. Tarun is? Tarun is also there. Let's check. Hmm. Okay, Ranjit. So now look here. I hope you might have understood this one. So we have understood that what was the Oersted conclusion that always we were talking about that magnet is needed and magnet will generate magnetic lines of forces. But first time we came to know that it was not the only magnet is there which can generate magnetic lines of forces. It is exactly current can also generate magnetic field. And actually in which direction? Perpendicular to the electric field. And we came to know another important point is south to north when the current is moving, the compass needle is deflecting towards first west and another time it was deflecting towards east. So when we are changing the placement of the compass from down to top, the direction of magnetic lines are changing. The direction of magnetic lines are changing. Another important point, so this was the first thing and I told you draw it because based on that they ask north to south and south to north, above or below. So these are two important things, above or below. Above means east, below means west. Understood? So you need to be very precise in this. Now the next point. So I'm reading out it and then line by line I'm going to explain this part. Now look here. The direction of deflection will also change in your, if you are going to change what? If you reverse the direction of current. Understood not? First what we did, screen is not clear. Arey yaar, what is the problem for me? Everything is clear coming. Yes, south to north. Screen is clear only, yaar. This PDF will be available to you. Now check, is it okay? Check. Now is it okay? Now I'm going to explain this part. Network, I can't do anything. I have called that person. Today, tomorrow, definitely I'm going to do some work. So the direction of deflection will also be changed if you reverse the direction of current beta. So the direction of current in the wire by interchanging the battery connection also will change it. Correct now? So if you are changing the battery direction also, the current direction will change, because positive and negative terminal will change. Understood? So if positive terminal and negative terminal will change, then current direction will also change. So if current direction will change, what will be the result? The compass needle deflection will also change. So change in direction, I hope you might have understood, change in direction of current will change the direction of magnetic lines of forces. Is it clear to you? Huh? Is it clear to you or not? So now, how to change the direction of electric current? By changing the potential difference direction, positive terminal and negative terminal. So if you change the positive and negative terminal, what will happen? The current direction will change. So now here one simple, you need to check this one out. Now here, if this wire is connected like this is the positive terminal. So that means what? The current is exactly moving in this direction. So it is going from south to north. Got it? It is going from south to north. Now, if the compass needle will be here, then it will deflect towards which direction? West direction. So this will deflect towards here. But if the compass needle is here, it will deflect towards which direction? East direction. Understood? This is towards west and this is towards east. But if we are going to, understood? So it will deflect towards east. But what will happen if we are exactly going to change it? Understood? So now the terminals we are going to change. Here it will become negative terminal, positive. So definitely positive terminal. Now here it is coming as positive terminal. Now this part will be coming as positive terminal. Correct now? So from the positive terminal, so this becomes the positive terminal. Now the current is moving from north to south. The current is moving from north to south. So once the current is exactly moving from north to south, and now we are keeping the compass needle here, so definitely the deflection will change. The deflection will change. Hmm. You are able to read out, can you tell me? Yes, for some people it is absolutely clear. Now look here, hey, go for the next one. Make sure that you pass a current through the wire only for short period. Understood? Allowing the current to pass through the wire for a long period will heat up the wire and considerably it will drain the battery rapidly. That's different thing. Understood or not? That's the precautionary measures. So I hope you might have understood this. The direction, hey, if you switch off the current in the wire, the needle will come towards the original position. Understood? And only for a short period of time only we can do this demonstration. So I hope till here everything is clear, beta. So new things will be here is, if I'm keeping it, now it will deflect towards again this direction, and this time it will come towards this direction if we will keep the needle. So definitely the direction south and what you call east and west direction will keep on changing, north to south and south to north. You remember, from because from this section one question they are definitely asking. So many a time they are asking this. I think you people network are having some problem. Can you check this? You network, you do one thing, come out of the live stream and then again join the live stream. It will help you. Come out of the live stream and again join the live stream. I'm changing the network and trying to see. Now can you check, beta, is the network okay? Hey, I am waiting for your answer. Is it now okay so that I can do my work? Shall I check your live? Okay. So this already we have studied. Now we are going to go for the next part. Now, magnetic field of a current, already oystered concept we have used. Did you saw the deflection is coming in which direction, beta? Correct, na? It will be deflected towards west direction. If it is the current is moving from north to south, the deflection is towards west direction. So this is what we have studied. Oersted performed an experiment to show the magnetic field setup. This already we have done. Current was allowed to flow. This already we know. The compass kept directly below the wire. What happened? The needle of the magnetic compass was found to deflect towards west direction. Understood or not? So it was exactly pointing towards west direction. But when we kept the magnetic compass, direction changed. Did you saw this part better? What is exactly not electric current was again allowed to pass to the same wire, but AB is now opposite direction. Now current is exactly in opposite direction. This time rather than going towards west, the needle is going towards east. Understood not? So that means we learned a very important thing that if the current is moving, listen children carefully, if the current is moving from south to north, the compass is moving towards west. Understood? And if the what you call current is exactly going from north to south, understood or not, the compass needle will move towards east. So this is the final outcome. And understood or not? So this is exactly the most important thing. So when we have talked about the direction and everything, it is exactly going to be the simple concept understandable to these ranges. I hope you might have understood this section, beta. We have already finished this part. Now we are going to go to the next section. Now with this we'll start maths also. So direction of deflection also we have understood. Now look here. When direction of deflection we talked about, so direction of deflection of needle to the magnetic compass will be what? Already we have studied electric current will be passing in that direction, and you will be seeing this law. What they have given is Ampere swimming rule. Understood? So now what they have talked about in this swimming rule, they told that considered a man swimming along the direction of current in the wire. So what is the direction? South to north. Understood? Now the electric current enter in his feet and leaves his head. So which direction it is exactly going to be? Yes, and it is exactly to the needle. The magnetic compass will deflect towards his left hand. Left hand means where? Yes, left hand means where? It will go towards. Come on. When the current is moving, see, don't go here and there. To the point content we need to learn. And that is south to north current moving means deflection is towards west. Understood? So if your hand is exactly left hand, west is what? When you are standing like this, you are north and this is south, down is south, and this part is east and this part is west. So definitely it will be this location only. I hope it is exactly, now it is buffering. What should I do, beta? Current today some problem is there. So this is Ampere swimming rule. Okay. So this Ampere swimming rule we have understood. Now that's what? That's the west direction we have understood. Now this is the last topic we are studying, because today one small surprise for all of you. And that small surprise is quickly we are going to start. Okay, now look here. Quickly, we are going to start maths also. Understood? Because exams are coming near and we need to do both the work together. So, maths and 2, 3 very awesome questions we are going to solve. Correct now? So, physics numericals also tomorrow morning we are going to do that work. Okay, because see, physics and chemistry part first to NCRT totally. Yes, correct now? Super beta. Yes, test will also be there, beta. Test 1, test conduction, Saturday, Sunday, we are going to do that. Full on revision we are going to do. So just we have understood about this content, about the oyster rule, compass needle deflection towards west. Understood? Now some experiments were there. These experiments we are going to do in the next class. I'll be drawing it and I'll be explaining that part. Okay. That was a simple concept, Abhishek, that the simple thing is when the current is exactly going from south to north, beta. See, understand the compass needle and the current direction you take same. Understood? Like my finger, my hand, south to north, and here also compass needle is pointing towards north. Now, beta, if the current is moving like this, the compass needle will definitely deflect towards this direction, west direction. This is what we had discussion about Oersted rule. Okay. Now the magnetic lines of forces and solenoid, everything we are going to study slowly. Magnetism we are not going to study so fast. Simple concepts, but with content we are going to study. Okay, I'm going to stop and I'm going to start again. Don't worry about that. Okay.